Hello. So, how many of you were at OpenSearchCon last year? And of those of you who were at OpenSearchCon last year, how many of you attended the Unconference? Maybe just Eric? Oh, man. So, yeah. Oh, and Chris, yeah. So, yeah. My title of OpenSearch is a database, is actually a reference to my Unconference topic last year, which was OpenSearch is not a database, where at the time I was railing against the way that OpenSearch tries to be sort of strongly consistent with like read after write consistency, at least through the GET API. I was like, no, forget all that. We should move to like a pull-based indexing thing where you have something like Kafka or whatever, and shards pull from that, and it's much more scalable. And anyone who's built like a very large scalable search system, like Amazon Product Search or something like that, you tend to do pull-based indexing. And so that was last year. This year, it's OpenSearch is a database, which is less focused on the ingestion side, more on the search side, which is, actually, I was just chatting with Asif and Akeshi, and I think it was Asif made the really good point that a lot of people in search tend to kind of define themselves as like not database people. Right, like that's one of these things where I count myself in that camp for a long time. Right, that it's like you end up bumping into relational database people. The worst is when you're trying to help someone onboard to a search solution and they're coming from the relational world and they're expecting their search to behave like a relational database. It's like it's not the same thing. The one that I always love is when people are like, how deep can I paginate? And you say, like, why? And they say, so that my users can like get the first page of the results and then sit there and click next until they get the result they want. I'm like, that is a terrible search experience. What you should do is like, I don't know, add some facets or something so that they can refine their search and bring the results they want onto page one. But that's also not really what I'm talking about. More recently, I've been trying to actually learn databases. I finished college 20 years ago, I guess. So this is kind of new and exciting for me to like go back and like really learn this stuff. Honestly, the distributed database world's pretty exciting, right? Like there are people doing all of these fancy data lake things where they're like streaming results from a bunch of different Parquet files, and then they have all of these essentially compute nodes that are combining results and doing complex computations. I'm like, what if you did both? What if you have these like clever Lucene powered shards where you do the nice Lucene stuff at the shard level that you can, but then you leverage the layer above it and start to do like streaming aggregations, right? Solar to some extent kind of does this. That Solar's had these streaming expressions for 9 years, I think. Yeah, 9-10 years. And we don't have that in OpenSearch. Why not? We could, and then this way, you can get into a model where you've got your Lucene data nodes that, again, do the things that Lucene's good at, but then, start streaming their results to some other node that can say, do a join, that can compute some statistics to do a lot of the heavy lifting of your aggregation. Why make your poor data node do all that work? Leave it to do the nice Lucene stuff, and just stream and have your intermediate things, and then you can have a whole neat network of these intermediate things. Have a query plan, right? And then you can optimize that query plan, right? Yeah. None of this is really stuff that people tend to do with Lucene because not a database, but. Yeah, what if we can learn from the database folks, especially from the OLAP folks? Like I'm not interested in turning OpenSearch into an OLTP system, but people frequently use it for analytics. That's a lot of our workloads, right? And it's like, well, that does overlap with OLAP, right? So yeah, let's learn from the OLAP folks. Steal their ideas. And since I have plenty of time, I will also give a plug to Professor Andy Pavlo from Carnegie Mellon. Teaches an advanced database systems course. It's a graduate level course. And all of his classes are up on YouTube. So I definitely recommend that you go and search on your phones CMU Advanced Database Systems, and yeah, you'll find the YouTube playlist. I'm about like halfway through the course. Like I still need to go all the way through before this is a fully baked idea. But this is what unconferences are for, is half-baked ideas. So yeah, I'm working my way through. I will just say that the end credits for each episode, the song that plays is a total banger. So yeah, questions? Yeah.
Don't we already have SQL in there? Don't we already have PPL?
Yeah. Well, so the SQL plugin is actually really interesting because it's Lior, forgive me if I'm disparaging you and your colleagues. Like, don't get me wrong, the SQL plugin is very good, very powerful, but it is a plugin. It is kind of attached to the side a little bit. So one thing is, it's kind of limited by the existing OpenSearch APIs, and this is part of what we need to change. And we are working to change it, and hopefully the SQL plugin will actually be able to take advantage of some of the preliminary things that we're doing. And in fact, some of our ideas came from the SQL plugin folks. So right now, for example, the way that it does a join, where it streams results from two different indices. So it was using a scroll for that, right? Where it would just, essentially paginate. It would also do what the database folks call early materialization, where it would paginate through like full search responses, right? Because it wasn't really hooked into the query versus fetch layer, right? So it would run the full query and fetch, get a full page of results, including the source, right? And then do joins based on that. Whereas it's like, well, what if, like if your join, ultimately only like 3 documents survive the join, and you've streamed all these documents with their full source, just to only have like 3 of them come out the other end, that's kind of wasteful, right? Whereas it's a lot nicer if you could stream just like doc IDs and join key, resolve the join, and then be like, okay, these are the doc IDs that survived. Now I'm going to go do the fetch phase. The SQL plugin, again, can't really do that because it has to treat that whole like query and fetch as a black box, more or less, because of the way that's not tightly integrated into the core. We do have a prototype. Rishabh, who's not here but actually works with near Lior in Vancouver, has implemented a prototype using Apache Arrow that actually hooks into the Lucene collector. So like as it's collecting documents, it's writing them to an Arrow stream that then can come back to the coordinator, and then you'd be able to resolve a join there. So yeah. So
some days.
Yes, there is an RFC. Well, actually, there are 2 RFCs in a way. So part of this, we have a joins RFC, and then Ankit wrote what started off as a query planner RFC, but has kind of evolved into this like query engine RFC. So yeah.
As a quick follow-up question. I've heard about Arrow for quite a while.
Yeah.
Can you give like the 30-second version of what it is? Because I think I've got a couple different ideas in my head. So maybe others have the same question.
So incidentally, I didn't have a really good understanding until I took Andy Pavlo's. Well, I started watching Andy Pavlo's database videos. So, how many of you know how Parquet works? Yeah. Okay. So, super quick. Classic OLTP systems, row-based. Everything was like stored in rows. And the reason for this is so that you could update a whole row. Like, ideally, the row would fit within like a file system block, so you could like update it atomically. And not have to risk like, oh, I updated this block, but then this block didn't get updated. So yeah. So then you get into OLAP systems where things, people were like, wait a sec, if we do columns, this is all much, much faster. Because you could just like rip through a column, resolving a join, computing the maximum of something, computing the sum of something, whatever, because you're just reading through those values. For the operating system, page caches, awesome. Now, Lucene, under the hood, is actually kind of like the OLAP systems, right? Those old OLAP systems that were column-based. So Parquet kind of switched things up, where it was like, what if you do both? Where you have these row groups. So you've got, like, say, 1 million rows, or I think Parquet does it as like number of rows. Yeah, so it's like 1 million, and then within those million, everything's broken down by column. So you kind of get the best of both worlds. Like you don't. It works really well when your data is stored in an object store, for example, because you could fetch a chunk at a time. You could do a range read from your object store, get a row group, and then rip through it without having to load like a lot of stuff into memory. Arrow is basically like that for the wire, right? So it's chunked, but then within each chunk, things are arranged in column stride. And a really cool thing is that depending on how you use it, it can also be zero copy, right? So you've got your arrow data, and you're just you don't have to deserialize it really, because you're just accessing the values because they're all fixed width. Yeah. Supports because it's also fixed width. You tend to be able to do random access within the chunk, right? So you're not having to do forward only. So yeah. Oh.
Hello.
Hello.
Question as sort of a comment, or comment as a question?
Yeah.
Next year's talk could be OpenSearch is a graph database, ... question?
Oh, Leor can give that talk. Graph databases are beyond my expertise. Well, on the other hand, I don't know. Next year, if somebody has like some graduate level graph database course and can send it my way, maybe. Yeah. So I think Leor had a question.
So basically, like, we already support order within the index.
Mm-hmm.
Can we do the same for knowing in advance that we would like to join an index or a segment with another segment? Can we pre-state the foreign keys so that they can be searched as well?
Yeah, so one of the things we've been talking about is like, what kind of merges do we want to support? With the obvious one being a hash merge, right? Because that's sort of the general one. But it was like, hey, what if both sides of your join are sorted by your join key, then you just stream them, join, and stitch them together. So that's cool, and Lucene supports index time sorting, and so if you know that you're going to be doing a lot of joins between these two things, joins on this join key, then by all means sort your index by that. I had a crazy idea that like I ran it by Mike Sokolov and Mike McCandless, and neither of them told me that it was like a terrible idea, which makes me think that it could be promising. I think there might be a way to add secondary indices to Lucene, where you could have a Lucene index that's sorted multiple ways. You will end up with some data duplication, just because you'd have to duplicate your postings lists essentially. But I'm like, I think you could actually kind of have a Lucene index with multiple sorts. At which point, you'd be able to do these sort merge joins. But again, this is something where it's like, an idea in the back of my head. I think it's still hard, but not impossible. Okay, that's my time. Thank you.